Hey everyone, Mr. Fransky here. We're going to talk about the last problems, 7 through 13, for those multiple choice problems that you have in your packet. So let's take a look at it and see what we've got. So all of our same vocab we've been talking about in all of chapter 3 is going to be good here. So we got f of differentiable function where f of 3 is 15, f of 6 is 3, f prime of 3 is negative 8, f prime of 6 is negative 2. G is the inverse of f. Ooh, interesting. What is the value of g prime of 3? So I'm going to have some point. So inverse functions, we always want to set this up. Some point is going to be on f. And then the mirror point, or the buddy point, is going to be on g, which is the f inverse. And we're going to find the slope of each one by using the derivative of this guy, and then the derivative of the second one is going to be the reciprocal. So let's see what we know. We know we want to find g prime of 3. So 3 is the x-coordinate on g. That means 3 is the y-coordinate on f. So I'm trying to find a point that has a y-coordinate of 3. F of 3 is 15. No, that's the x-coordinate. I don't want that. Here, f of 6 is 3. Ah, that works. 3 is my y-coordinate. That means 6 is my x. So then 6 goes here for the g. So I want to find the slope of f at 6, 3. I want to know f prime of what coordinate? 6, right? So f prime of 6, oh, they give me that. It's negative 2. That means the slope for g is 1 over negative 2, which is negative 1/2. There it is. It's A. Little tidbit, this is the most missed multiple choice question ever. And they give you all the information. Basically, they give you a table, right? But people have struggled with these inverses, right? It's just the reciprocal. It's all you have to do. All right, next up, we got x ln x squared. We want to know f prime of x. So it looks like we're going to have to use some product rule and maybe some chain rule as well. So f prime of x, derivative of x is 1. Leave the ln of x squared alone. Plus, this time we have x times a natural log derivative, which is 1 over x squared. Then we have to multiply by the derivative of the baby function, which is 2x. So let's see here. That gives us ln x squared. Looks like both of these x's cancel. Okay, so x squared is just gone, so it's just plus 2. So 2 plus ln of x squared. There we go, B. All right. Here we got a quotient of functions, so we have to find f prime of 1. So let's find f prime of x first. Low d high, x plus 1 times the derivative of the top, which is 1, right, because it's just linear, minus high d low, x minus 1 times 1, that's the derivative of the bottom. Over the square low we go, x plus 1 squared. Okay, so that is x plus 1 minus x plus 1, right, because that negative distributes, all divided by x plus 1 squared. So let's see, x minus x, those go away. So we have 2 over x plus 1 squared. We're going to evaluate that at x equals 1. So that looks like 2 over 2 squared, which is 2/4, which is 1/2 d. Nice. All right, cosine squared 3x. They want to know the derivative. So y prime, 2 comes to the front, cosine of 3x, right? So really this 2 coming to the front, the baby function is everything inside. So cosine 3x, I've got to multiply by the derivative of cosine 3x. That's going to require chaining again. So we're going to have negative sine of 3x, and then we chain the baby inside again, times 3. So what does it look like? We got 6, negative 6, because of the negative here, sine 3x, cosine 3x. A. There we go. I was going to say, they might have done something sneaky with the fact that you 2 sine x cosine x is sine 2x. That's an identity you might remember from last year. So you could have maybe done something with that in here, ended up with a 6x inside. But they didn't do that, so thank goodness we don't have to think about our identities. All right, number 11. Limit as h approaches 0, 1 over h ln of 2 plus h over 2. Now, we've seen this enough that this probably should smell like a derivative to you at this point. It's not quite in the same form that we're used to seeing, right? We know that f prime of x is equal to the limit as h approaches 0, f of x plus h minus f of x divided by h, right? It doesn't quite look like that. Let's write this a little bit differently, though. So what we have here is ln of 2 plus h over 2 divided by h, right? If I just slide the whole thing up and multiply it by 1 there. Now, this is getting closer, right? Now we have an h on the bottom, but I want to turn this into a subtraction. Going to have to dig deep on this one. Remember your log rules, right? A division here turns into a subtraction. This is ln of 2 plus h minus ln of 2 divided by h. Oh, now it looks a whole lot like this, right? This is the derivative of natural log evaluated at 2, right? Because I plugged 2 in here. So this is the situation where we really have an a in here instead of an x. So they're trying to find the specific value for f prime of 2. Well, I know f prime of x for ln. It's 1 over x. So f prime of 2 is 1/2. That's it. Did we just get 1/2 like 3 times in a row? There's a 1/2. There's a negative 1/2. Yeah, a lot of 1/2s. Okay, so moving on. If y equals e to the nx, then they want to know the nth derivative of the function itself. So what I usually do here is I find the first few derivatives. So y prime would be, so you leave e to the nx alone, then multiply by the derivative of the baby function, which is n. I'd write that as n e to the nx. Y double prime would be the derivative of this guy. So the n is a constant, so forget about it for a second. Derivative of e to the nx is once again n e to the nx. So that is n squared e to the nx. Y triple prime, you probably already see the pattern, right? N is going to come to the front again. It'll be n cubed e to the nx. So the nth derivative is going to be n to the nth power e to the nx. Do we have that? There it is. It's a. Cool. Moving on. One more. Once again, we have a derivative definition. This is just the derivative of sine x. Easiest problem on the thing. Cosine. Done. Cool. Don't spend any time doing limits there. And that's the end of the multiple choice problems. Not too bad. Hopefully this was helpful. I will see you in another video. Love you guys. That's why I'm here. Have a great day.